Let's discuss the scenario where one primary fuse opens on a delta-grounded Y transformer secondary voltages. This typically involves a situation where you have a power distribution system like a 12,470 volts to 480 volts Y with 277 volt system. Now consider the question: what happens to the secondary voltages line to line and line to neutral when one of the primary fuses supplying the delta primary of this transformer opens up? Essentially, one of the phases on the primary side is lost. The secondary voltages will react in a specific way. First, looking at the line-to-line voltages on the secondary side, which are the phase-to-phase voltages across the phases, these will remain balanced at 480 volts. This is because the delta-connected primary windings continue to act as a closed loop even with a single open phase. This closed-loop action on the primary helps to maintain a balanced magnetic flux, which in turn creates balanced line-to-line voltages on the Y secondary. However, the line-to-neutral voltages on the secondary side behave differently. The line-to-neutral voltages do become unbalanced. The phase that is connected to the open primary phase will see its voltage drop to 0 volts. This is because the phase is essentially disconnected from the source due to the open fuse. The other two phases on the secondary will maintain their respective voltages, and you'll see voltages of approximately 277 volts on each of these phases. This is the secondary source voltage divided by the turns ratio of the transformer. This behavior occurs because the grounded Y connection provides the neutral point on the secondary side. When one primary phase is lost, the magnetic flux distribution within the transformer becomes uneven. Although the delta primary maintains the line-to-line voltages, the individual phase voltages on the Y secondary are affected by the lack of flux contribution from the missing primary phase. So the phase connected to the open primary loses its voltage contribution, resulting in 0 volts line to neutral, while the other two phases continue to function normally at 277 volts. For further reading and in-depth technical explanations, you can refer to established resources. For example, Electrical Power Distribution Systems 8th edition by Taran Gurnan, specifically pages 335 and 336. Also, the Electrical Engineering Handbook 4th edition by J. G. Fink and H. W. BT Section 15, pages 15-151 provides relevant information, and IEEE Standard 31-2016, which is the IEEE standard for electric transformers, contained applicable guidelines and specifications.